Multiple times on this show, we have discussed the astonishing repeated discoveries of soft tissues still preserved in the fossil record, with a particular fascination for dinosaur tissues and even blood still preserved in fossil dinosaur bones. Now, last year, two researchers from the Creation Research Society published a paper detailing the finding of more soft dinosaur tissues preserved in a Triceratops horn. One of those researchers was Mark Armitage. Mark studied biology at the University of Florida. He holds a master's degree in biology with emphasis on electron microscopy from the ICR Graduate School. All his biological training is going to prove important for the subject at hand today. He is currently a doctoral candidate at Liberty University in the School of Education. He served as adjunct professor of biology at Master's College for 3 years and adjunct professor of biology and electron microscopy at Azusa Pacific University for 4 years. Mark's micrographs have appeared on the covers of 11 scientific journals, and he has published over 30 technical papers on microscopic phenomena in such journals as American Laboratory, Southern California Academy of Sciences Bulletin, Parasitology Research, Microscopy, and Microanalysis. He is a lifetime member of the Creation Research Society and is past president for the Southern California Society for Microscopy and Microanalysis, currently serving as treasurer. He joins me now via Skype, and I have wanted to have you on the show for quite some time, so welcome to the show, Mark.
Thank you, Ian. It's great to be here. And yes, some of those long words are real tongue twisters, aren't they?
Yes. I'd like to start off with the iDino project. Now, I've talked about it here on the show before, and you've been heavily involved with it. What can you tell us about it?
Sure. Well, thank you, Ian. It's great to be with you. I appreciate the opportunity to be able to speak to you and your listeners and viewers. So we have a little show and tell today, which we'll get to, but iDino, what is iDino? iDino is an acronym that we came up with because we wanted something catchy that people could remember, but it does have a meaning. It stands for Investigation of Dinosaur Intact Natural Osteotissue, meaning we're studying dinosaur remains, mostly their bones, and we're looking for intact, natural, in other words, pre-existing original osteotissue or bone tissue. And because bones are interesting organs in your body. They are organs. They're comprised of a lot of mineral, calcium phosphate, other minerals, but they also have a lot of soft tissue in them. And there is a particular very interesting part of the soft tissue called an osteocyte, which is a bone cell. And they come in several different flavors. We can maybe discuss a little bit of that. But osteocytes are very characteristic cells. And any microscopist, any person who's done any study of bones, of really any mammalian, even reptilian or amphibian bones, avian bones, recognize osteocytes instantly. There's just no confusing an osteocyte with any other kind of cell. And so they're a wonderful cell to go hunting for in dinosaur tissues. Now, we began this work because, of course, we, as well as you and probably your viewers and most every creationist on the planet, was very excited to see the work of Mary Schweitzer, who is a researcher, a paleontologist from North Carolina State University. And she published a series of very interesting papers where she went to the Hell Creek Formation in Montana, which is a very well-known fossil graveyard. In fact, it's well known for Triceratops, but also T-Rex. And they found a very large T-Rex fossil and a very large femur. And of course, when you're in the field as a paleontologist and you want to remove bones, you jacket these things. First, you paint them with a plastic, a methyl acrylate, and then you bind it up with essentially casting material. Like if you broke your arm, you would put on a cast. Well, they put casts around these bones, then they flip them over and they put a cast on the other side, and they pull them out of the dig. And so, as everybody knows, this large femur that she had was too heavy to be lifted out by helicopter, and so they had to fracture and saw the femur up, and she sent some pieces back to her lab, and you know the story. She dissolved some of these in a weak acid and found all this soft tissue in it. She's found blood-like vessels and blood-like cells. They don't use the terminology. This is a blood cell, and this is an osteocyte. They call it an osteocyte-like cell because they don't want to state the obvious for whatever reason. But I'm sure they have their little paradigm to protect. But in any event, we were very excited about that work, as were most people. And so we went to the Hell Creek Formation in May of 2012. And we spent 3 days searching and digging, and we found the largest Triceratops horn ever located on that ranch. About a 48-inch long, 9-inch wide, intact, what they call a supraorbital horn. As you know, the Triceratops has 3 horns, and this was one that was over the eye, supraorbital. It was above the eye, very large specimen, and but it was in a very bad state of decay. It was fractured into many pieces. When we took it out, it fractured into many pieces. It was filled with plant roots. It was filled with mud. It was kind of moist. Really unlike the femur, the T-Rex femur that Schweitzer found, which was completely encapsulated and encapsulated with this hard bone mineral, all the soft tissue inside. No. The horn that we found was highly vascular, had a lot of holes in it where the vascular bundles went through, and it was loaded with this wet mud. They call it matrix. It was loaded with matrix. So it must have been exposed to fungi and bacteria and algae and insects, microorganisms. I mean, it runs the gamut of what it could have been filled with, plant roots. So we were rather dejected, frankly, when we pulled it out of the ground. We thought, we're not going to find anything here. But I brought it back to the lab, and I worked on it for about 6 months. And lo and behold, we not only found osteocytes, but we found entire sheets of osteocytes. I mean, stretchy pieces of material that were, maybe 3 to 4 centimeters long that you could stretch like a piece of taffy and let go, and it would come back into conformation. And so I thin sectioned some of that and looked at it under the microscope. And here I have a microscope, which I'm going to show you some images from in a second here. But I thin sectioned that and located these osteocytes in 3 dimensions. In other words, you could focus down through the tissue and see these osteocytes placed throughout the whole z-axis in that tissue. So we were stunned by this, and of course it's way different from the find that Mary Schweitzer and others have found, because this shouldn't have been there at all. This should not have been there even after. Well, we would think these things were buried, maybe 4,000 to 6,000, 8,000 years ago, maybe. Even in that time frame, this stuff shouldn't be there. And so it's really an enigma, and I've gotten in trouble because I tell people I think it's a miraculous preservation. I think God miraculously preserved this for us to find it. I get in trouble. You'd be surprised, a lot of creationists call me out on that one, but I do. I really think that God chose this specific time and us for this task to find these things, and so we published it. We published this in a major journal. In fact, it got fast-tracked into the journal. I think it was 30 days from the time we submitted it until the time that it was accepted, which is unheard of. Most of my papers take a year to a year and a half to get published, and so this was published very quickly. And of course, at the time, I was running an electron microscope laboratory, a premier multi-million-dollar laboratory at California State University, Northridge, in the biology department. And the paper was published. Before that, one of the pictures of the soft fibrillar bone mass with the osteocytes in it was published on the cover of American Laboratory. And that didn't sit well with some of the faculty members. And so shortly after the paper was published, I found myself out on the street and without a job.
Very frustrating. And you are not the first this has happened to.
I'm not the first one that it's happened to. It is frustrating because I made no conclusions in the paper. I just presented the factual data. The only conclusions that I drew were that this needs to be investigated further. We have a lot of work to do. and that was it. And so to be and I have to tell you, I can't talk much about the situation with the university right now because I have attorneys and they're preparing a lawsuit, and the lawsuit is about to be filed. And so suffice it to say that some people in the department didn't appreciate it, and somehow they seemed to work a way to have me very quickly removed from my position. I'd been there for over 3 years, 38 months. I'd received many accolades from many of the professors. In fact, the chairman of the Department of Biology wrote me a letter of recommendation, and he said, Mark is probably the best staff member that this department has ever hired. And that at that point, it was a 50-year-old department, so I felt rather proud of my accomplishments there. And so it's very unfortunate, and I really feel sad for the students who were learning the skills of microscopy and abruptly had to change in midstream in the middle of their master's theses because I got yanked out of the lab. And I was the instructor of record. I was teaching scanning electron, transmission electron microscopy, of course light microscopy with the light microscopes, and also confocal microscopy, these brand new fluorescent microscopes which use lasers and really cool technology. So it was very disappointing to be thrown out as a result.
Now, as we've discussed here on the show before, certainly the findings of Schweitzer and team were not the first. There was reports of dinosaur blood found in dinosaur bones back in the 1920s. So neither this finding nor Schweitzer's were the first.
No. My paper was not the first. In fact, this was not my first paper on this phenomena. Back in early 2000s, I published a paper in the Creation Research Society Quarterly. I received a T-Rex, a piece of a T-Rex femur that had been in a museum drawer for about 100 years. And so I fractured it open and I found soft tissues inside of it. So this was actually my second paper. And also it's rather frustrating because when I interviewed for this position at California State University, Northridge, I gave my entire publication history, which included all of my Christian and creationist publication. I gave full disclosure on who I was. They knew who I was. In fact, there is even a critique on the California State University Northridge website, a critique of one of my papers written about 10 or 15 years ago by a geologist at CSUN who just excoriated me on my paper, and so it's on their website. So anybody could have searched Armitage and CSUN, and this critique of my work would have popped right up. So I didn't do anything nefarious. I was completely above board and open about my position. I didn't try to proselytize people, but I did what my professor, Dr. Richard Lumsden, the late Richard Lumsden, who was with the Institute for Creation Research, and he was also with the Creation Research Society. He used to say to me, "My boy, don't be afraid of where your science takes you." And so Dr. Lumsden, I hope I'm doing you proud because I haven't been afraid of where my science has taken me.
Okay, so the iDino team went looking for soft tissues.
Well, yes. In the horn and also in ribs, we found Triceratops ribs. And of course, all this is presented in the paper. By the way, the paper was published in an international journal called Acta Histochemica, which is a journal of cells and tissue. And so it was a natural fit for that journal. And it was published in 2013. So it's readily available. In fact, if you just Google Armitage Triceratops, the paper will come up and you can go and purchase it online from Elsevier. And Elsevier is a rather large publisher. They publish The Lancet, they publish Cell, and they've been publishing since about the 1600s. So I think they know a thing or two about publishing. So it was a great honor to be published in that journal. And but yes, we found soft vessels in the horn and in the rib, mostly in the rib. It appeared that most of the vessels were permineralized or fossilized inside the horn. But also very interestingly, in the rib, we found, because we fractured away some of these vessels, and inside those vessels, you could see all these tiny round microstructures, which we had to call red blood cell-like structures. we couldn't just come right out and say these are red blood cells, but they're obviously packed inside the vessel. The vessel's soft and pliable, and you've got all these round structures in there. I mean, come on, and any common sense person would say that looks like blood, and those look like blood vessels. And but interestingly, in the horn, most of the blood products were crystallized, and so. And the iron, the heme group and the hemoglobin does this. When it desiccates, it'll crystallize and form these beautiful little crystalline structures with very squared off edges and sharp edges. And so you can see that. And all the vessels were permineralized. They were all hardened. But on the other side of that, between the vessels and the hard bone mineral, were these sheets of soft bone tissue. Before they get hardened, these osteocytes are really cool little cells. They actually they come from blood cells. They descend from the white cell line, and they differentiate into what we call osteoblasts and osteoclasts and then osteocytes. So there's 3 different types. The osteoblasts, of course, are building cells. So they're busy building bone. And so what they'll do is they'll all line up in the same direction. They're all linearly in the same direction on the same plane, and they will cement themselves in with this bone mineral. But at the same time, they build little tunnels between cells. They're called canaliculi. They're tiny little tunnels, and then they put a little thread called a filopodia. It's an extension of the cell. And all these filopodia go in all 3 directions, and they're all touching each other. All these bone cells, even in hard bone, are all touching each other, and they're all alive. And so what they're doing as you're walking or running or stretching or exercising, they're measuring the mechanical stress in your bones as you're doing these things. And so they will decide which area of the bones need to be deconstructed and repaired, and others can stay the way they are. And so osteoblasts build the bone mineral, osteoclasts dissolve the bone mineral, and those populations have to stay equal throughout your lifetime. Now, what happens when you get osteoporosis? Well, the osteoblasts die off. And so the ones that are building bone cell die off, and the osteoclasts are busy deconstructing bone. And so you get big voids inside your bone that are not repaired because the osteoblasts are dying off. So they give you a drug that increases the population of the osteoblasts and keeps those populations equal. And so I think I heard somewhere that your entire bone is replaced every 12 years with these little cells that do this. And so it's crazy. It's really an amazing area of study in anatomy, and I would encourage anybody to do a unit on bone cell morphology and structure and function. It's crazy what these things are doing. But as I say, these osteocytes are characteristic. You recognize them instantly. And so when you're dealing with a dinosaur bone and you find osteocytes in it, and I'm going to show you some here on this screen here. I think you can see on this screen here. These are bone cells. That's an osteocyte right there from a dinosaur cell, and it's on this microscope. That's one single cell which we've isolated out. These cells are so characteristic that to claim that your bone is contaminated with something from the environment is ridiculous.
That's a major point.
It's a huge point because the contamination claim is, well, there's osteocytes from some other more recent organism sequestered inside that bone. So you're asking me to believe that a bird or something died next to this fossil Triceratops horn, and that the bird somehow broke a wing as it was crashing into the ground and dying, and the osteocytes had the presence of mind to crawl out of the bird bone and hunt around and find a Triceratops horn and crawl deeply into the Triceratops horn and take up residence in the proper conformation. Remember, these things are all aligned in perfect XY space. So they're all pointed in the same direction. and all on the same plane. So it's ludicrous to make the contamination claim. And so we don't see that claim made too much more these days. The other claim has been that these are bacterial biofilms. And what is a biofilm? Well, these microorganisms, when they're busy breaking down nutrients that they find in the soil, they want to go get that stuff. You know, that's food for them. And so they break it down and they consume it. And in their place, they make this sort of sugary film that they all live in. And somehow that sugary film, this biofilm that they made, took on the very shape of this perfect little osteocyte, which is, it's ridiculous to assume that the biofilm could take on a shape like that. I mean, these are very characteristic shapes of bone cells. And not only that, we're seeing inside the bone cells nucleus-like structures. Now remember, we can't call them nuclei. We have to call them nuclear-like structures, right? But here you're expecting the biofilm to not only find the proper place where the osteocyte is, replicate it in its entirety, including the internal organelles. I mean, it's ridiculous to assume this. And so the biofilm theory has gone by the boards. In fact, Mary Schweitzer did an excellent series of experiments whereby she actually found in the nucleus-like structure, she found histones, which are the packaging proteins that package up DNA. As you know, DNA can be strung out into long, thin strings, which it's deconstructed that way in order to copy it, right? In order to copy DNA in a messenger RNA, it has to be unwound. But the winding up is done by these proteins called histones that wind and super wind and triple wind and quadruple wind until we get these chromosomes, what we recognize as chromosomes. And so she found actual dinosaur histones inside the nucleus-like structures in this wonderful series of experiments. So I think we've all agreed now that this is real dinosaur tissue. It's staggeringly amazing that this lasted the supposed 65 to 70 million years and didn't decompose. And now she's published a recent paper which says, well, it was the blood. It was the blood that somehow preserved it. And again, it's like a 10th grade science project to publish a paper like that. That's just too fantastic.
So even within the paradigm of a 6,000-year-old Earth, with these dinosaurs being killed 4,500 years ago in a worldwide flood, these preserved tissues are an astonishing find.
It is astonishing. And one of the things that I learned in microscopy, particularly my master's program, and as I've continued to do research, when you want to study tissues, particularly under the electron microscope, fast preservation is paramount. We try to be as humane as possible when we're sacrificing organisms for study. I mean, that's the least we can do is anesthetize them and you know, expire them gently. But we have to almost instantly perfuse their tissues in a strong chemical called a fixative. You've heard of formaldehyde. Well, there's others. There's glutaraldehyde, which is one that's preferred in electron microscopy, followed by osmium tetroxide. And these are very dangerous chemicals that require the use of a hood and goggles, and you can't breathe this stuff. And so why do we do that? Because we're very interested in the shapes and in the morphology of the tissues. And if we don't preserve them quickly, and often we do this on ice, we'll put our specimens on ice, because autolysis, the natural breaking down of tissues, is a standard MO. It's a standard operating procedure for all cells. When they die, they release these chemicals that just deconstruct everything and break it apart so that the proteins, the amino acids, and everything are usable. And so autolysis is a really serious problem. It's compounded when the tissue is found in water. In the presence of water, it's even more highly destructive. And so that's why, you know, I'm going to stick to my guns, and I'm going to continue to say that I think this preservation is really pretty much miraculous. I think God somehow has preserved these things for us to find and to get out to the general public. and show them that this tissue is there. It has to be young. It cannot be old at all.
Now, you put together a DVD on the research and put a video on YouTube as well. Please tell us about the DVD.
Sure, absolutely. The iDino DVD has a lot of photos of the dig. It has a total description of the dig. It describes our laboratory. It gives an overview of the kind of instrumentation that we use in our laboratory. For example, a lot of people are not familiar with the different type of light microscopes. So we talk about light microscopes, dissecting and compound. We talk about the scanning electron microscope. We talk about the transmission electron microscope. And we give a basic understanding of how these things operate, because it's pretty technical. So we try to explain it in a way that's easy for the average person on the street to understand. And then we talk about how the tissues get processed, how they get put into the microscopes, how the images are taken. And then there's video of all the different types of microscopy that we do. You can see the stretchiness, you can see the osteocytes. We actually focus through a very deep section of tissue. And we'll start out on the top surface, and we focus all the way through and all the way back up. So you can see all these osteocytes placed in this thick tissue that we found. What else? I guess, it shows my laboratory at California State University Northridge, all of the microscopes and equipment that we use there. So it's a fairly comprehensive treatise on what did we find, where did we find it, how did we process it, what the results were, and the equipment that we used it in, the laboratories that we used it in. It's an hour long. It's $25. People can email me, and I can email them the information about it, and we mail it right out for people who order it. But it's very high quality. It's got video shot through the microscope, and they can see that stretchy stuff. There's 2 or 3 places on the DVD where I show the stretchiness of these tissues.
And people can get a sneak peek of what's on the DVD from your YouTube video. What are we looking at here?
Essentially, what it shows is about maybe a 5 or 6 centimeter long, 3 centimeter wide, flat ribbon of this tissue, this sheet of tissue that we found deep inside the horn, and I grab it with 2 very fine needle forceps, and I stretch it. And I stretch it in 2 different axes, and as I let go, you can see it come back to its original conformation. So just like a piece of taffy, you would stretch that. I stretched it out, let it go, and it came back to its original form. And again, I subsequently took that tissue and I thin sectioned it very thin, and you can see that it's loaded with all these bone cells, these osteocytes. So it is, in fact, actual bone soft tissue from the dinosaur that was stretchy and that we thin sectioned and showed you the structure inside.
So how many bones did you examine searching for soft tissue before you found these ones?
Well, that's a great question. We actually started with a bunch of bones that had been collected years and years ago because we wanted to work out the protocol. We wanted to understand what the scientific procedures were so that we would be ready when we did find a bone which might have soft tissues in it. And so the first year of the project, I concentrated on learning how to dissolve the bones in a weak acid. It's called EDTA. So I learned how to work up the reagents, how to process the bones, and of course everything dissolved because there was nothing soft inside of them. But so by the time I got to Glendive, Montana, the Hell Creek Formation, I was ready. My laboratory skills were ready. And so when we found the horn, again, I said earlier, we were very disappointed because we thought this is not going to yield anything. And I was shocked, frankly, when I got it back to the lab and I started taking it apart, dissecting it, and finding the different pieces of soft tissue in it. So at that point, I was ready to do the decalcification and remove all the bone mineral and expose all the internal piping. It's kind of like picture a cement slab, like in your kitchen. You've got a cement slab and you've got all this piping inside of it, and there's liquid water and soft stuff that goes through the piping, but everything else is hard. Well, the bone is like that. It's got all this concrete around it called bone mineral, and inside are all the blood vessels, the piping. And so we use this acid to dissolve away all that concrete and get to the piping. So that's essentially what we did. Yeah. So now I can tell you also that we're in the process of working with a piece of frill, Frill, and this, of course, is that large piece that came up off the Triceratops cranium and covered the back of the neck. And so that whole piece of frill, we're starting to look at that now for the same kinds of tissues and cells. We haven't had any luck yet, and I think the frill that we're working with was out of the ground for too long. I think it was out of the ground for about 2 years, and so we're planning to go back to Montana this spring and see if we can't find some more frill. I will say that our discovery of the soft tissue in the horn was a world first. No one had found that before, and so we're hopeful if we find it in the frill, we can publish that quickly, and that would also be a world first. So the charge that creationists are brute beasts that have no training, they don't understand science, they certainly don't practice science, they don't work in scientific positions, they don't do any research because they don't understand science, and they've never published anything. All of those objections are certainly blown away with the work that we're doing with iDino. And we need to get the word out that particularly with the Creation Research Society, about 700 practicing scientists with advanced degrees, and of course we have a large membership beyond that, but 700 to 800 PhD and MS, advanced degree scientists who are practicing in their field. And there's a lot more. There's a lot more that are still in the closet, and they don't want to come out for obvious reasons. We get fired from positions when we make an impact and show that we can do science too. And so it's much easier for them to just throw us away than it is to debate us on the world stage.
Now, you had some other exciting facets to all this research. What can you tell us?
Yes, the new research is the frill. However, we have made some new discoveries with respect to the Triceratops horn. As I mentioned, osteocytes are very easily recognizable cells. And so in the first paper, what we concentrated on were the sheets of tissue which had the osteocytes embedded in them. And so this was soft tissue with the osteocytes in place. Well, what I didn't do, which is what Mary did, is she looked at the solutions after the bones had been soaked in this acid for a while. She pipetted out some of those solutions and looked in there and found free-floating osteocytes. And so she never found sheets of osteocytes. She found some pieces of osteocytes sort of connected together, but she didn't find the large sheets that we found. She did, however, find the stretchy blood vessels. We didn't find those. But again, I think it's because that T-Rex femur was just a solid jacket of hard bone mineral that was protecting all that soft stuff inside. The Triceratops horn has a completely different anatomy from a femur. It's a completely different kind of bone. Well, we're greatly encouraged because we've made several new discoveries with the Triceratops horn since the initial publication of the paper. And one example is that we went back and looked at the solutions when you dissolve these things in a weak acid. We hadn't looked at the solutions previously because we found these entire sheets of tissue, so they're loaded with osteocytes. So we thought, why bother? But we did go back and we looked at those, and we found tons of individual free-floating osteocytes. And so we've documented all that. We've taken a lot of pictures of that, and we've also learned to handle individual cells and fix them onto slides, because that's important if we want to do the histone work. Like Mary did on the T-Rex femur, we want to go look for histones in those osteocytes as well. So learning how to handle these individual cells and fix them on slides so they're not moving around, that's been tricky, but we've mastered that now. And also we found a tremendous amount of collagen inside this soft tissue. We did a test called the Picrocereus red stain, which stains for collagen. So we found a large amount of collagen, and we've taken pictures of that, so we're looking forward to publishing that. But one interesting thing is we took a piece of the outer horn and we shipped it off to a carbon dating lab, and they tested it out at about 30,000 years, plus or minus a couple of thousand years, which is very encouraging, particularly since these bones are supposed to be 65 million years old.
Give or take a week.
Yeah, give or take, a lifetime. But we're looking to send, and we have now sent a part of the horn core, which is the very densest part of the inside of the horn, back to a dating lab, and we expect that number to come way down because it's loaded with collagen. And in the presence of collagen, carbon dating goes way down, so we expect to be within 10,000 years or less on those dates. And we've also sent pieces in for DNA analysis. So since the initial publication, we've had some very exciting discoveries and results, and we're looking forward to publishing the new stuff.
Awesome. And we'll look forward to having you back on the show when you get more published.
Wonderful. Well, we'll be happy to come and give you all the details when all that gets published.
Now, apparently you're working on a children's book related to this as well.
Yes, we are working on a children's book. It's going to be illustrated. It's for children ages maybe 7 and up, maybe to age 99. I don't know. I still feel like a child. But it's called, it uses an osteocyte we call Old Stretchy. And so Old Stretchy is an illustrated bone cell who tells the story of the Triceratops horn throughout the book. It's going to be in color, hardcover, fully illustrated, and a lot of pictures too of the actual work that we've done. So we're looking forward to publishing that. And if people want to email me, I can send them a pre-publication order form, and they can get a special price if they order it before we publish it. So if you want to post that, we can do that.
Well, Mark, this has been absolutely fascinating. Thank you so much for coming on the show. I know the viewers will really appreciate this. So from them and myself, thank you.
My pleasure. Thank you, and we'll do it again when you're ready.
You can contact Mark for more information about his book and the iDino Project DVD via email, micromark@juno.com. Now, research does cost a tremendous amount of money, but you can see the fruit research bears. And I can testify that Creation Research Society is very prudent with their funds and has accomplished an awful lot with extremely little. I know they would appreciate your financial support for the iDino project, as well as many other research projects they fund, and you can support them at creationresearch.org. This interview was edited for television, but you can catch the entire fascinating interview on our YouTube channel. Just head on over to genesisweek.com and you can find it there. Stick around. We'll be back in 1 minute.